Hi guys, in the previous lecture we have covered the AC transient free condition in which we have derived the formula for RL and RC circuit at what time the RL and RC circuit will be transient free. So we have solved some problem based on AC transient free condition also. Now in this lecture we will be covering two-port network. So before studying two-port network, I would like to define what is port. What do you mean by port? Basically, port is the pair of terminal from which a current can enter or leave a network. Means it is a pair of terminal from which current can enter or leave a network. For example, if I will take a case of transformer, in transformer we know that we have a primary winding and secondary winding. The primary voltage is V1 and the primary current is I1. Similarly, the secondary voltage is V2 and secondary current is I2. Okay. So, this is port 1. This is defined as a port 1 and this is defined as a port 2. Why? Because see here, the current is entering into the coil and leaving from the coil. That's why it is known as port, because current is entering into the coil and leaving into the coil and the magnitude of current is same, that is equal to I1 only. So this is known as one port and this is also known as one port. So overall we can say that net current entering or leaving is equal to 0 in any port. In this way we can define a port. Now why two-port network is necessary to study? Basically, a two-port network is the way of modeling any system in terms of parameters. Like we have 6 parameters available: Z parameters, Y parameters, T parameters, T dash parameters, H and G parameters. So these are the 6 parameters available in two-port network. So in any circuit we can model that circuit in terms of these parameters, and these parameters are independent of how the circuit works. Parameters are independent of how the circuit works. So in nutshell we can say that a two-port network is necessary because we want to model any system in terms of these parameters. So basically we define two-port network that it is a way of modeling any system in terms of parameter. Like in transmission line, we model the transmission line in ABCD parameters. Similarly, for BJT, we model BJT by H parameters. We model transformer in terms of T parameters. So these all circuits we can model in these parameters. That's why it is necessary to study two-port network. So let us define the two-port network. A two-port network is an electrical network for two separate port for input and output. Here this is known as input port and this is known as output port, and in between these two port the parameter is represented. Okay, so we have total 4 variable v1, v2, i1, i2, and out of these 4 variable we have to take 2 as an independent variable and 2 as a dependent variable. So how many different selections can be possible? We have to select 2 variable from 4 different variable. So total number of combination is possible for C2, that is equal to 6. That's why we have 6 parameters available in two-port network known as Z parameters, Y parameters, T parameters, T dash parameters, G parameters and H parameters. So before starting two-port network, let us understand the concept of symmetrical network and reciprocal network. A network is said to be symmetrical if we divide the network in two parts, then one should be the mirror image of other, or if network looks same from the both input and output ports. Similarly, a reciprocal network can be defined as which a network is said to be reciprocal which obeys reciprocity theorem. Means the ratio of response to excitation will be same when the input and output terminal gets interchanged. So these reciprocity theorem I have explained in earlier lecture. Let us take one example. Let us take this network and I have to find whether it is symmetrical or reciprocal. See, for symmetrical, if we divide this network in two parts, then one should be the mirror image of other. Means let us take, I am dividing this network from here, then I am not getting the mirror image after dividing. Means this is asymmetrical. See from here and see from here. Okay, the parameters are different. Like here I am getting 2 and here I am getting 1. So overall this is asymmetrical. And we know that all passive network are reciprocal. So this is passive network. So we can say that this is reciprocal. Take this example. If I will divide the network from here, then I will get the mirror image of this network. Means this is symmetrical and this is reciprocal to as this is passive network. Now take this example. If I will divide this network from here, then I will get different input impedance. When I will calculate V1 upon I1, then I will get different input impedance than V2 upon I2. Means V1 upon I1 is not equal to V2 upon I2 because here the resistance is 2 and here the resistance is 3. So overall we can say that this is not symmetrical network, this is asymmetrical. Now this network contains a dependent source, means this is an active network, so we can say that this is non-reciprocal. In this way we can find the symmetrical and reciprocal network. Got it? Now let us move to the 6 different parameters that we defined, that total number of combination is possible, that is equal to 4 6 C2. That means 6 parameters are available: Z, Y, T, T dash, G, H. Let us define each one of the parameters separately. Let us take first Z parameters. What do you mean by Z parameters? This is also known as open circuit parameters. Okay, so in any kind of network we define that network in terms of Z parameters, and in Z parameters V1 and V2 are the dependent variable while I1 and I2 are the independent variable. Why this is known as dependent variable? Because the value of V1 and V2 is depending upon the value of I1 and I2. That's why it is known as dependent variable, while I1 I2 are the independent variable. So we defined the Z parameters in V1 is equal to Z11 I1 plus Z12 I2. Similarly for V2 is equal to Z21 I1 plus Z22 I2. Now the condition for symmetrical is, in Z parameters, if Z11 is equal to Z22, then this network is said to be symmetrical. Means this Z11 must be equal to Z22 for symmetrical network. Similarly for reciprocal network, Z12 must be equal to Z21. Z12 is here, must be equal to Z21. Got it? Now let us consider Y parameter. Y parameter is known as short circuit parameter. Why Z parameter is known as open circuit parameter? Because if you open this secondary terminal, let us take, if I am opening this secondary terminal, the value of I2 will be 0. Since the value of I2 will be 0, so put I2 is equal to 0 here, you will get Z11 is equal to V1 upon I1. So in this way we find Z11. Now suppose we have to find the Z12. So for finding Z12 we have to open circuit the input port. If I will open circuit this input port, then I1 will be equal to 0. Put I1 is equal to 0 here, then you will get V1 upon I2, that is equal to Z12. So while calculating Z parameter, we have to open circuit the input port or output port in order to find Z11, Z12, Z21 and Z22. That's why it is known as open circuit parameter. Now in Y parameter can also be defined as Y is equal to Z inverse, and in this Y parameter I1 I2 are the dependent variable while V1 V2 are the independent variable. So we can represent any kind of network in Y parameter. I1 is equal to Y11 V1 plus Y12 V2. Similarly I2 is equal to Y21 V1 plus Y22 V2. So this is exactly opposite to the Z parameter. So in matrix way we can define I1 I2 like this. Okay, now it is also known as short circuit parameter. Why it is known as short circuit parameter? Suppose you have to calculate the Y11. So in order to calculate the Y11, you have to make V2 is equal to 0. If you will make V2 is equal to 0, then Y11 you will get I1 upon V1. So how will you make V2 is equal to 0? By short circuiting this secondary port. So if you will short circuit this port, then you can easily calculate Y11. Now to calculate Y12, you have to make V1 is equal to 0. So short circuit this input port, you will get Y12, that is equal to I1 upon V2. So in order to find the Y11, Y12, Y21, Y22, we have to short circuit the input and output terminal. That's why it is also known as short circuit parameters. Now for symmetrical, there is condition Y11 must be equal to Y22, and for reciprocal Y12 must be equal to Y21. These things you should remember, because question is asked directly whether the network is symmetrical or reciprocal. Got it? Now let us consider the T parameters. T parameters is also known as ABCD parameters. Okay, and these parameters are used while modeling the transmission line. So in T parameters, dependent variable are V1 and I1 and independent variable are V2, I2. So we can represent T parameter in equation like V1 is equal to AV2 minus VI2 and I1 is equal to CV2 minus DI2. See, in previous parameters Z and Y we are taking plus, but while defining ABCD parameters we are taking negative. Why? Because in ABCD parameter the direction of current is opposite to the what we have assumed in two port network. See, here the direction of current is entering to the port, and here also the direction of current is entering to the port. That's why we are taking positive. However, in ABCD parameters the direction of I2 is reversed. That's why we are replacing I2 as minus I2. So if you will replace I2 as minus I2, you will get minus. Okay, in matrix form also we can represent V1 I1, this is the sending end voltage and sending end current, and V2 minus I2, this is the receiving end voltage and receiving end current. Now for symmetrical, A must be equal to D, this must be equal to this, and for reciprocal AD minus BC must be equal to 1. Similarly T dash parameters is also defined. This is the inverse of T, we can represent as inverse of T. Now in T dash parameters, V2 I2 are the dependent variable and V1 I1 are the independent variable. So V2 is equal to A dash V1 minus B dash I1 and I2 is equal to C dash V1 minus D dash I1. For symmetrical, A dash must be equal to D dash, and for reciprocal A dash D dash minus B dash C dash is equal to 1. Okay, now let us take H parameters. In H parameters, V1 I2 are the dependent variable and I1 V2 are the independent variable. So V1 is equal to H11 I1 plus H12 V2 and I2 is equal to H21 I1 and H22 V2. Generally these parameters are used to model BJT. Okay, now in this parameter the condition to be symmetrical is H11 H22 minus H12 H21 must be equal to 1, and the condition for reciprocal is H12 must be equal to minus of H21. means this must be opposite to this one. H12 must be equal to minus of H21. Similarly, G parameters is the, we can represent G parameters that is equal to H of inverse. Okay, here I1 V2 are the dependent variable and V1 I2 are the independent variable. So I1 is equal to G11 V1 plus G12 I2 and V2 is equal to G21 V1 plus G22 I2. And in this case the condition for symmetrical is G11 G22 minus G12 G21 is equal to 1, and condition for reciprocal is G12 is equal to minus G21. So these 6 parameters we are going to study, and we will take many circuit in order to find the Z parameters, Y parameters, T parameters, T dash parameters, so that you can understand the modeling of any circuit or any device. Okay, now let us take some problem based on this. The Z parameters of network is given by Z is equal to 1, 2, 3, 4. We know that Z can be represented as Z11, Z12, Z21, Z22 in matrix form. Then the network is, we have to find whether this network is symmetrical or reciprocal. Now in Z parameters, I have already explained you the condition for symmetrical is Z11 must be equal to Z22. Okay, means this must be equal to this. So 1 must be equal to 4 here. 1 is not equal to 4. So we can say that this is asymmetrical. Now for reciprocal, Z12 must be equal to Z21. This is Z12 must be equal to Z21. Means these two must be equal. Here it is not equal. So we can say that this is non-reciprocal. Okay. Similarly, we have to find the symmetrical or reciprocal in T parameters. In T parameters, what is the condition for symmetrical? A must be equal to D. This is A and this is D. 2 is equal to 2. So we can say that this is symmetrical network. For reciprocal, AD minus BD, AD minus BC must be equal to 1. AD is 4 minus BC is 3. 4 minus 3, that is equal to 1. So this is also reciprocal network. Okay. Now let us take third problem. For two-port reciprocal network, the output open circuit voltage divided by input current, means output open circuit voltage is V2 divided by input current, that is equal to I1, is equal to what? So if I will talk about the Z parameters, then in Z parameters, output open circuit voltage V2 upon I1 is nothing but Z21. Okay, so output open circuit voltage V2 upon I1 is equal to Z21. Got it? Now for reciprocal network, Z21 must be equal to Z12. So option C is satisfying this condition. So Z12 must be the answer. Most of the guys get confused. Z21, they can represent Z21, that is equal to 1 upon Y21, but this is not equal to 1 upon Y21. Remember this. When we will derive the relation between Z parameter and Y parameter, then you will see that Z21 is not equal to 1 upon Y21. Okay, for reciprocal network, Z21 must be equal to Z12. So option C is correct. Now let us look at this network. This is T network. Okay, and in T network we have to find the Z parameters. So I am going to explain you two methods for finding any kind of parameters. Okay, first is by KVL approach, KCL approach, nodal approach, whatever you want to use you can use, and the second method is by open circuiting or short circuiting. See here, I1 current is flowing here, I2 current is flowing here, means at this node in this branch I1 plus I2 current will flow, right? Now apply KVL. If you will apply KVL, then you will get V1 is equal to I1 ZA plus I1 plus I2 ZC. means ZA plus ZC I1 plus I2 ZC. Now compare this equation with a standard Z parametric equation. What is Z parametric equation? V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. Okay, if you will compare with a standard equation, then you will get Z11 is equal to ZA plus ZC and Z12 is equal to ZC. Okay, now apply KVL in second loop here. If you will apply KVL in second loop, you will get V2 is equal to I2 into ZB plus I1 plus I2 into ZC. So finally I will get ZC I1 plus ZB plus ZC I2. Now compare this with a standard equation. V2 is equal to Z21 I1 plus Z22 I2. So you will get Z21 is equal to ZC and Z22 is equal to ZB plus ZC. So in matrix form we can represent this Z parameter as Z11 is, we have derived ZA plus ZC, this is ZC, Z22 is ZC, Z21 is ZC and Z22 is ZA plus ZC. So whenever you will get any kind of T network, then you have to remember this, that Z11 you are getting this value ZA plus ZC, okay, and Z22 you are getting, sorry, this is ZB, okay, you are getting ZB plus ZC. So Z11 is the open circuit input impedance. Why open circuit? If we will open circuit this V2 terminal, then I2 will be 0. So Z11 I am getting V1 upon I1, that is the open circuit input impedance. Similarly, Z22 is the open circuit output impedance, that is equal to ZB plus ZC, and this Z12 and Z21 are same, that is equal to ZC. So remember this will help you while deriving the complex network. Okay, so one method I have already explained you, that is to apply KVL, or you can apply nodal in order to find any kind of parameters. The second method is more simpler than the first method. How? Let us see. We have V1 is equal to Z11 I1 plus Z12 I2. We have to find Z11, Z12, Z21 and Z22. Okay. So first method I have already explained you by using KVL. The second method is the open circuiting method. Means if I have to find the Z11, if I will make I2 is equal to 0, then I will get Z11 is equal to V1 upon I1. So now make I2 is equal to 0, and this is open circuit. It means ZV is of no value. So overall circuit will look like this, right? This is V1, this is I1, and since the current flowing in this outer side I2 is equal to 0, so there will be no I2 current flowing in ZC. So overall you will get I1 current from ZA and ZC. Now find V1 upon I1, you will get ZA plus ZC. In this way you can find all the parameters. Like if you want to find Z12, Z12 is nothing but V1 upon I2 when I1 is equal to 0. If I will put I1 is equal to 0, then Z12 is equal to V1 upon I2. Put I1 is equal to 0 here. Okay. Now find Z12. Z12 that is equal to V1 upon I2. I2 is flowing, the circuit will look like I1. Since I1 is 0, so I am not considering any drop here. I am getting only ZC, okay, and this is ZB. I2 is flowing like this and coming like this. Since the current flowing in this ZA, I1 is 0, so overall I2 will flow in the ZC. Now you have to find V1 upon I2. Apply KVL here. Since there is no drop across ZA, so V1 is equal to I2 ZC. So V1 upon I2 is equal to ZC, that is equal to Z12. In this way we can find all the Z parameters by open circuiting the input or the output terminal. Okay, so finally I will get Z11 is equal to ZA plus ZC, and Z22 is equal to ZB plus ZC. Similarly, Z12 is equal to ZC and Z22 is equal to ZC. Remember this. Let us take one more problem. We have to find the Y parameter of pi network. This is pi network, okay, and I have to find the Y parameter. First write what is the equation of Y parameters. Equation of Y parameters is equal to I1 is equal to Y11 V1 plus Y12 V2, and I2 is equal to Y21 V1 plus Y22 V2. Now let us see in this circuit, at node this the value of voltage is V1, okay, and at node this the value of voltage is V2. Now apply nodal at node V1. Apply nodal, I will get minus I1 plus V1 by A plus V1 minus V2 upon impedance, that is equal to YC is equal to 0, okay. So I1 I am getting YA plus YC into V1 plus minus YC into V2. Compare this with the equation, with this equation you will get Y11 is equal to YA plus YC and Y12 is equal to minus YC, okay. Similarly, apply nodal equation at V2. At node V2, V2 minus V1 into YC plus V2 YB minus I2 is equal to 0. So I am getting I2 is equal to minus YC V1 plus YB plus YC V2. So Y21 I am getting minus YC and Y22 I am getting YB plus YC. In this way we can find the Y parameter, okay, by applying nodal equation. The second method I have already explained you. You can approach that method also. Like we know that the Y parameter is the short circuit, also known as short circuit parameter. So if I have to calculate the Y11, then I can easily calculate Y11 is equal to I1 upon V1 when V2 is equal to 0. So in order to calculate Y11, I have to short circuit this V2 terminal. If I will short circuit this V2 terminal, then this admittance is of no use. Like if I will short circuit this V2 terminal, then the circuit will become like this is YA, this is YC, and this is short circuited, okay. This is short circuited, so YB of no use. This is I1 and this is V1, this V2 is 0. Now apply nodal equation here. You will get minus I1 plus V1 YA plus V1 YC. So I1 upon V1 is equal to YA plus YC. In this way you can find by short circuiting input and output terminal in order to find the different Y parameter, that is Y11, Y12, Y21 and Y22. Now let us look this problem. We have to find the T parameter of inverted L circuit. Okay, so first write the T parameter equation. V1 is equal to AV2 minus BI2 and I1 is equal to CV2 minus DI2. Now apply KVL in first loop. This is first loop. I am getting V1 is equal to I1ZA plus I1 plus I2ZB. Take equation first. Now apply KVL in this. You will get V2 is equal to I1 plus I2 into Z2. Hence I1 is equal to V2 upon Z2 minus I2. Equate this generalized equation with this equation. You will get C is equal to 1 upon Z2 and D is equal to 1. Okay. Now you have to find the value of A and B. For that you have to put the value of I1 in the equation first. If you will put the value of equation 2 in equation first, that is the value of I1 in equation first, you will get V1 is equal to ZA plus ZB upon ZB into V2 minus ZA I2. So this will be A and this will be B. Put the value of I1 in equation first and simplify. You will get same like this. Okay. In this way we can find the ABCD parameter, that is known as T parameter of inverted L. Now you have to find the Z parameter of this network. Okay. So I have already explained you the Y parameter of pi network. This is the Y parameter of pi network in which I am getting this is YA, this is YB, this is YC. So Y11 is equal to YA plus YC, Y12 is equal to minus YC, Y21 is equal to minus YC and Y22 is equal to YB plus YC. So we can represent this question in terms of pi network like this. This is Z, this is having infinite impedance, means YA is equal to 0. Okay, and this is also having infinite impedance, so it will be open circuited, means YP is equal to 0. So in this way we can represent the above network by in pi network. Okay, now apply the formula whatever we got in pi network. So this will be YC is equal to 1 upon Z. So we can write exactly Y parameter as this we have derived in previous problem. Okay, now we know that YA is equal to 0, YB is equal to 0, YC is equal to 1 by Z. So we can finally say that this is 1 by Z, this is minus 1 by Z, this is minus 1 by Z, this is 1 by Z. Okay, now in order to find the Z parameter, we know that Z is nothing but inverse of Y, or Y is equal to Z inverse. So if I know the Y matrix, then we can easily find the inverse of Y matrix in order to find the Z parameter. Now let us find the inverse of Y matrix. So I have one shortcut which you have to keep in mind. Suppose any matrix is given A, B, C, D, and you have to find the inverse of this matrix, then this is given by 1 upon AD minus BC, that is equal to determinant of this matrix, and interchange the diagonal element, means D will be here, A will be here, and take minus sign, in the remaining element. This will be the inverse of the ABCD matrix. This is valid only for 2 cross 2 matrix. Okay. Now Y matrix is not, so Z is equal to Y inverse. For that we need to find the determinant first. So if you will find the determinant of this Y matrix, you will get 0. So Z Y inverse does not exist. For any matrix, if determinant is 0, so Y inverse does not exist. So finally we can say that Z parameter does not exist. Got it? So we can find only Y parameter of this network. Now let us see this. This is T network, and we have already find the Z parameter of T network whose Z matrix is given by ZA plus ZC. This is ZC, this is ZC, and this is ZB plus ZC, where ZC is this, ZA is the input here ZA is equal to 0, and this is ZB is short circuited, so ZB is equal to 0. So Z parameter is given by ZP, ZP, ZP and ZP. Okay, now you have to find the Y parameter. We know that Y is equal to inverse of Z, and in order to find the inverse of Z matrix, first we have to find the determinant, and if we find the determinant, then I am getting determinant of Z is equal to ZP square minus ZP square, that is equal to 0. So inverse of Z matrix is not possible, so Y parameter does not exist, means it cannot be defined. Got it? Now let us see the problem number 9. This is delta connected and we have to find the Z and Y parameter. So first convert this delta into a star. So you will get the circuit like this, having 1 ohm, and after converting from delta to star, the value I will get, that is equal to 111. So overall this will be like a T network, right? And for T network we know how to find the Z parameter. We can write this whole as a 2, right, because these two are connected in series. Now find Z parameter. We know that this is ZA, this is ZB, and this is ZC. So Z is equal to ZA plus ZC, that is 2. This is ZC, this is ZC, and this is ZB plus ZC, that is equal to 3. Now we have to find the Y parameter. Y is equal to Z inverse. Now in order to find the inverse of Z matrix, we have to find the determinant of Z, that is equal to 6 minus 1, that is equal to 5. So 1 by determinant of matrix 5. Now replace, interchange this diagonal element 3, 2 and use minus sign with remaining element. This is the Y matrix. In this way we can find the Z and Y parameter. Now see this question. We have to find the H12. That means we have to write the equation of H parameter. What is the equation of H parameter? V1 is equal to H11 I1 plus H12 V2, and I2 is equal to H21 I1 plus H22 V2. Okay. Now we have to find the H12. What is H12? This is H12. So we can write H12 is equal to V1 upon V2 when I1 is equal to 0. Put I1 is equal to 0 here, you will get this 0 value. So H1 is equal to V1 upon V2. Since I am considering I1 is equal to 0, means there will be no drop across this resistor, right? No drop means whole voltage will drop across this resistor. This is V1. Got it? Because no voltage drop across this resistor. Now apply voltage division rule in this circuit. Okay, when you will apply voltage division rule, then you will get V1 is equal to R V2 upon R plus R. So V1 upon V2 is equal to 1 by 2, that is equal to H12. In this way we can find any parameter. Now let us see this problem. In this two-port network, ABCD parameter is given. A is equal to C is equal to 1, B is equal to 2 and C is equal to 3. And we have to find input impedance, means this is Zin. So Zin is given by, input impedance is given by V1, input voltage upon input current, V1 upon I1. Okay, so finally I have to find V1 upon I1. Since ABCD parameter is given, so first write the ABCD parametric equation, that is equal to V1 is equal to AV2 plus BI2. Okay, why I am taking as a plus? Because I2 is going inward. If I2 will be like this, then I have to take minus. Since in problem the polarity of I2 is given inward, so we will take as a plus. Okay, and I1 is equal to CV2 plus DI2. Now see, what is V2? V2 is equal to, we can write V2 in terms of I2 and this resistance. So V2 is equal to minus of I2 into 10, that is equal to minus 10 I2. Replace V2 from equation 1 and 2nd, I will get. Now divide equation 3rd and 4th, I will get C plus B. Put the value of A, B, C, D as given in the question. I will get, sorry, this is not A is equal to C is equal to 1, this is A is equal to 1. Okay, and that is equal to D, and this will be D, because I1 is equal to CV2 plus DI2, so this will be D and this will be D. So put the value of A, B, C, D here, you will get minus 10, A is equal to 1 plus B 2, minus 10 plus 2, that is minus 8, and minus 10 C, that is equal to minus 30, plus D is equal to 1. So finally I will get 8 by 29. Now see the last problem. In this problem also we have to find the input impedance, but the difference is we have Z parameter given. Okay, the network is represented in Z parameters. So same procedure can be applied. We know that input impedance is equal to V1 upon I1, Zin is equal to V1 upon I1, we know this. Now first write the Z parametric equation. Z parametric equation can be written as V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. We have to find V1 upon I1. So anyhow we have to replace this, the value of I2, so that we can represent this equation in terms of V1 and I1. Now take this equation as a 1 and equation as a 2nd. Now replace V2. V2 is given by, see, V2 can be represented in terms of I2 and resistance, that is equal to minus 2I2. Okay, replace V2 as a minus 2I2 is equal to Z21 is equal to Z11 Z12 Z21 is 0.6, 0.6 I1 plus Z22 is equal to 1.6 I2. Okay, so from here I am getting I2 is equal to 0.6 in minus divided by, so I2 is equal to, I can say, minus I1 by 6. Now put the value of I2 in equation first, you will get V1 is equal to Z11 is equal to 2.1 I1 plus Z12 is the 0.6 I2, that is equal to minus I1 by 6. So finally 2.1 I1 minus 0.1 I1. So V1 upon I1, that is equal to Zin is equal to 2 ohm. So that's all about this lecture. In the next lecture we will see interconnection of two-port network, series, parallel and cascade connection, and some problem based on these connection. Okay, if you guys understood the concept, then please like this video and subscribe to this channel. For doubt solving, you can join our Facebook group. Thanks for watching this video.